All right, we need to talk about a tech project that is so massive, so ambitious, it sounds like it's been pulled straight out of a science fiction movie. But here's the thing, it's very real. It's called Project Stargate, and it's a plan that's literally set to redefine the future of artificial intelligence as we know it.
So, what's the price tag for building this future? Get this, a cool $100 billion. That's not a typo. That is the reported budget that Microsoft and OpenAI are putting on the table for just the next phase of their AI infrastructure.
And what on earth does that kind of money buy you? Well, it buys you the world's very first computational fortress. Now, I want you to understand, this is not just another data center. Stargate is being designed as a single, gigantic supercomputer, a beast capable of housing millions of AI chips all working in concert, like one unified synthetic brain.
Look, with a price tag like that, we're not just talking about an investment anymore. This is a monumental gamble, a bet the company kind of move on where the future of technology is headed.
Just to try and wrap our heads around that $100 billion figure, we're talking about a sum of money that's bigger than the entire GDP of many countries. It's over 100 times more expensive than the biggest, most advanced data centers that even exist right now. This isn't just taking the next step, it's a quantum leap into a completely different league.
And this quote right here, it perfectly sums up a fundamental shift that's happening. The race to build the best AI isn't just about who can write the cleverest code anymore. The new battlefield is all about physical stuff. Who can build the biggest, the heaviest, the most power-hungry machines on the face of the planet.
So, that brings us to a pretty obvious question, right? Why the sudden obsession with building these massive physical structures? Why does the next big leap in AI depend on building something so enormous? Well, the answer is actually pretty simple. It's a fundamental limitation that the entire industry is crashing into at full speed. You could call it the energy wall. Project Stargate is estimated to need at least 5 gigawatts of power. And not just for a moment, but continuously. That is a truly staggering, almost unimaginable amount of energy for a single facility.
This chart really just drives the point home. Look at a typical data center's power needs. It's that tiny little sliver on the left. Even a large city consumes way less power than what Stargate is going to need. It's not just a little bigger. It is completely off the charts.
And here's the real kicker. There is nowhere on the current U.S. power grid that can just deliver 5 gigawatts of electricity to a single customer. It's impossible. Our public infrastructure was just never ever designed for that kind of concentrated demand. So, if you can't get the power you need from the grid, what do? You build your own. And this is where the plan goes from just being ambitious to being absolutely revolutionary. This slide shows you the new paradigm they're creating. The old way was to plug into the public grid, maybe add some solar or wind. The Stargate way, you forget the grid entirely. You go completely independent by building your own dedicated nuclear reactors right next door to the supercomputer.
The specific technology they're betting the farm on is called Small Modular Reactors, or SMRs. You can think of these as a new generation of nuclear power. They're smaller, they're more scalable, and they're designed specifically to be built on-site to provide a constant, reliable, and absolutely massive source of independent power. I mean, just stop and think about the implications of that for a second. When a computing facility has its own independent nuclear power source, it's not really just a data center anymore, is it? It becomes a strategic national asset, something as geopolitically important as a military base.
Okay, so solving the energy problem is a huge, huge deal. But believe it or not, that's only one piece of the puzzle. To win this new hardware war, you also have to control the silicon brain inside the fortress.
For a company the size of Microsoft, being totally dependent on a single supplier, in this case, NVIDIA, for the most critical component of your entire AI strategy, well, that's seen as a fatal weakness. This quote makes it brutally clear. It's basically financial and operational suicide. So here's their game plan for breaking free. It's a path to what you could call silicon independence. Step 1. Design your own custom AI chip, which they've called Maia 100. Step 2. Fine-tune that chip so it's perfectly optimized for the software it's going to run, in this case, OpenAI's models. And finally, Step 3. Achieve total end-to-end control over the entire system, from the nuclear fuel all the way up to the algorithms.
When you put all of these pieces together, it becomes crystal clear that we have entered an entirely new era. So, welcome to the new hardware war. I mean, just look at this side-by-side comparison. It really says it all. A traditional data center in 2024 might cost $1 billion, runs on the public grid, and uses chips you buy from NVIDIA. Project Stargate, it's a $100 billion project powered by its own private nuclear reactors and running on custom silicon. It's not even the same species of machine.
So when you boil this whole thing down, what does it all mean? What's the final verdict? For me, 3 things really stand out. First, AI is no longer just software, it's a physical giant. This is a game of infrastructure now. Second, the atom is the new fuel for algorithms. Nuclear power is becoming essential for cutting-edge AI. And third, designing your own chips isn't a luxury anymore. It's mandatory if you want to survive.
Which leaves us all with one final, absolutely monumental question. Is a project like Stargate the necessary, audacious leap we need to finally achieve artificial general intelligence? Or is this the beginning of a technological black hole? A project so massive, it's destined to consume ever-increasing amounts of our planet's energy and resources? That's the $100 billion question.